Hello dear students. So last time we were studying capacitors with dielectrics. Okay. Then the series combination of dielectrics and the parallel combination of dielectrics and the mixed combination as well. And then calculating the equivalent dielectric constant. We are done with those problems. Okay. The next example, which is only for JEE. Okay. This question can never be asked in NEET and never asked in the AIMS as well. Okay. So it's only for JEE Mains or JEE Advanced. Okay. Now it is like this. This is a parallel plate capacitor. Area is given, that is called A, and separation, that is D. And it is this capacitor is filled by a slab whose dielectric constant is K. But this K, it's not constant. It varies with x, and it is given by this K is equal to K naught multiplied by x, where K naught is the constant. So that means at this very point x is equal to 0, and dielectric constant will be equal to 0. So at this point it's equal to x is equal to D. So dielectric constant K will be equal to K naught multiplied by D. And as you go from this point to this point, the dielectric constant varies. Okay, so dielectric constant is not constant. Okay, so the question is like this: calculate the capacitance of the capacitor. So what to do? What we'll do is this: we'll assume that this entire dielectric slab is made up of infinitely many and vanishingly small elements. Okay, so like this. What I will do is this: I will chop this entire dielectric slab into small pieces, and this is one such piece. And this one such piece. Okay, so this is one such piece. Okay, now beta, suppose that its width that's equal to x, and it is at a position of x, at a distance of x from the origin. So this is x here, and its width that's equal to dx. Okay, so let's try to calculate the capacitance of this. Capacitance of this denoted by, I will write here, capacitance of element. Capacitance of element is given by, that is, I will denote it by dc of this element. Okay, so very small capacitance, that will be equal to, what is the capacitance of parallel plate capacitor? That is simply equal to K multiplied by epsilon 0 multiplied by A. Area of this is, if this is A, this is also equal to A, so multiplied by A divided by the width, that's equal to dx. Like this it is. Okay, now beta, simply it's K into epsilon naught A divided by dx. Okay, or you can write it like this: this is dc is equal to K will be replaced by this, so it is equal to K naught multiplied by epsilon naught multiplied by A into x divided by dx. So this is DC, which is the capacitance of this very element. Now we want to calculate what? We want to calculate the net capacitance. Okay, so there are many elements. Suppose this is another element, and then this is another element, and so on. Okay, now if you clearly see, all these elements, are they connected in series or they are connected in the parallels? Obviously they are connected in the series. Like this element, this capacitor, this capacitor, this capacitor, another capacitor, they are connected in what? Series. Okay, and the series, we know that the equivalent capacitance C is equal to like this. In series we write like this: 1 divided by Cs is equal to summation of 1 divided by Ci. Okay, now beta, so here I will write down equivalent capacitance, equivalent capacitance, or the net capacitance. Equivalent capacitance or net capacitance is, it's like this. Okay, so here we have series, all these elements are connected in series, so the equivalent capacitance will be given by this: 1 divided by C is equal to this summation. It will be replaced by integration, because the reason is that number of elements here, it is infinitely large. Okay, so it will be replaced by integration 1 divided by dc. बोलो बेटा ये समझ में आया? dc is the capacitance of one element, and all these elements are connected in series. That means the equivalent capacitance will be given by this equation: 1 by c is equal to integration, not summation but integration of 1 by dc. ठीक है ना बेटा? Okay, so it will be like this. अब ध्यान रखो बेटा, so here it's 1 divided by c is equal to integration of reciprocal of this. Okay, so reciprocal of this will be what? It will be like this: 1 divided by K naught epsilon naught multiplied by A. All these are constants. Now integration of reciprocal of this, so integration of dx divided by x. And what about the limits of the x? The limits of x will go from 0 to d. Okay, so 0 to d. Okay, now beta? Okay, now it will be like this: 1 divided by C is equal to 1 divided by K naught epsilon naught multiplied by A. And integration of 1 by x, what's that? That's obviously ln of x. So it is ln of x. Limits are from 0 to d. Okay, so it will be upper limit minus lower limit. Ln of 0 is 0, so it will be ln of d. So what I will write is this: it is equal to, this interval equal to 1 divided by K naught epsilon naught A multiplied by ln of d. Okay, okay, now finally what's the answer? Now what's the capacitance? So here I will write it down. So finally I will write it down here, that the C is equal to reciprocal of this, so it is K naught epsilon naught A divided by ln of d. Okay, so this is the answer. This is the answer to this problem. Okay, so I'll repeat it a bit. So first of all, here we have this parallel plate capacitor, the area of the plates is given, that's called A, and the separation between the plates, that's how much, that's D. But this time there's a dielectric constant. Whose dielectric constant? There's a dielectric slab whose dielectric constant varies with the distance and varies with the x, as this, that's K is equal to K naught multiplied by x. Now we are supposed to calculate the equivalent capacitance. So what I will do is I will chop this into many pieces, into infinitely many pieces, calculate capacitance of one such piece, and then go for the integration. So this is one such piece. Its capacitance will be this dc is equal to dielectric constant multiplied by epsilon naught multiplied by area, that's A, divided by the width, that is dx for this. Okay, then dc is like this. Simply K can be replaced by K naught multiplied by x, where K naught is a constant. Equivalent capacitance is given by this 1 by C is equal to integration of dc, because all these elements are connected in series. They are all connected in series, so that's why 1 by C is equal to integration 1 by dc. Okay, na beta? Okay, then next what I will do is this, I will substitute this equation here, reciprocal of this. Then integration of 1 by x is ln of x. Then lower limit will be 0, upper limit will be d, so it is ln of d. Then take reciprocal of this, so that we'll get capacitance. So finally the answer is this. Okay, so very important problem. You pause screen and write down. Okay, example number 2 of same pattern. Of similar pattern, that there is a dielectric whose dielectric constant varies with the x. Okay, na beta? But this time it is given to you that is here one plate and this another plate. Okay, and these are two terminals. For example, this terminal A and this terminal B, and we are supposed to calculate the equivalent capacitance between the terminals A and B. Okay, na beta? And then what is given to you is this, that this side is A, this is D is the separation between the plates, and this side length of the plates is A, and it is depth like this. That's equal to B. So that the area of these plates, that's equal to A multiplied by B. And K is given to you, that's equal to K naught multiplied by x, implies it varies with x. Okay, na beta? Now again the question is same, that calculate the capacitance of the parallel plate capacitor. Okay, so again what we'll do is this, we'll take one element. Okay, suppose the width of this element is equal to dx. Okay, and it is distance from here to here, that's equal to x. Okay, separation of this position of this element from this origin, the origin is equal to x. Now let's try to calculate the capacitance of this. So here I will write down capacitance of element. Capacitance of element is, that is dc will be equal to K multiplied by epsilon naught multiplied by its area multiplied by area divided by width divided by the separation between plates. Okay, na beta? This is the way we define it. Okay, so that means this dc will be equal to this k के बदले हम क्या लिखेंगे, that's equal to K naught multiplied by x. Okay, multiplied by this epsilon naught multiplied by the area of the plates. Now this time the area of the plates will be this, and this will be equal to dA, and the dA will be in turn equal to that's equal to it is depth, that is B multiplied by dx. So B into dx. Yes, on man, it's like this is a rectangular strip like this, whose width, this width will be equal to dx, and this length, this depth, that's equal to B. So it will be B multiplied by dx multiplied by B. Can I beta? So that is B into dx. Okay, dA. So here I will write on what, area, that's equal to what, B multiplied by dx divided by the separation between the plates. That separation between the plates is obviously D. So here I will write down D. Okay, yes, someone may I beta? This is dA, that is equal to B in dx. Substitute here, separation is obviously equal to D, so this is dc. That's the capacitance. Okay, one element. Now what you want to calculate is that net capacitance or equivalent capacitance. Net capacitance is C. Okay, now this is another element and this another element. Now all these elements, they are connected in series or parallels. This time they are connected in parallels. Okay, because this is one capacitor, this another capacitor, this another capacitor, they are connected in the same plates. So if these are the two terminals of the battery, that means the potential difference across this, potential difference across this, potential difference across this will be same. That means they are connected in parallels. And in parallels we know that, this equation Cp is equal to summation of Ci. ठीक है ना बेटा? So here I will write down this net capacitance C will be equal to not summation but integration of these, like this, integration of these. Okay, then I will write it like this, it is equal to, all these variables are constants. What's constant here is K naught, epsilon naught is a constant, B is a constant, divided by D is a constant. So integration of what, x with respect to x. ठीक है ना बेटा? Integration of x with respect to x. And what about the limits of x? Limits of x will be from here at this very point x is equal to 0. Then at this point x is equal to a, so the limits will be from 0 to a. Okay, now what's the net capacitance C? So it will be like this. This implies, this in turn implies that the C will be equal to this here K naught epsilon naught B divided by D. You know beta? Integration x is what? X square divided by 2. Okay, so x square divided by 2, I will write down 2 here. then x square, and upper limit is a, lower limit is 0, so it is simply a square. So this is the answer. On solving this integral, we have what? X square divided by 2, lower limit will be 0, upper limit will be a, so x square, so that means a square divided by 2. So 2 here and a square here, so this is the equivalent capacitance. Taken a beta? Simple. Take an element and x whose width is dx. Calculate its capacitance. Capacitance of this will be equal to k into epsilon naught a multiplied by its area. Area will be like this, that is equal to b into dx, because its width is b, its depth is b, and its width is dx, so b into dx. Okay. Then their equivalent capacitance will be like this, because they are connected in parallel. So you can write down they are connected in, all these elements are connected in parallel. That's why this integration. Okay. So pause screen. Again, it's important only for JEE. Okay, it is important only for JEE. As of now, a question has not been asked in AMS and NEET on this pattern. Okay, but the question can be asked in JEE Main and JEE Advanced as well. Okay, so you write this question, very important. Okay, example number 3, like this. It's an S-Verma example, also in I-Erodo and asked in JEE Main 2019. Okay, so let's try to solve this. This is a parallel plate capacitor. Okay, so these are two plates. Okay, so this here one plate, this another plate. Area is given to its a by a. A by a implies that its length is also a, its depth is also a. Okay, and then the separation between the plates that's mentioned, that's t. And here we have two dielectric constant. This is one whose dielectric constant is k1. This another whose dielectric constant is k2, like this. Okay. Now the question is that calculate the equivalent capacitance. Okay, between the points a and b. Again, what I will do is this. I will again assume that there is an element like this. Suppose that here we have an element, we'll calculate the capacitance of this and then integrate. Okay, assume that it is made up of infinitely many and vanishingly small elements. Calculate capacitance of one such element and then integrate. Take it, beta? Okay. Now what we'll assume is this. Suppose that this at a distance of y from here, at a distance of y from here. Okay, and its width that is equal to dy. Let's take this dy and this point here. Suppose here this distance from here to here, that is equal to x. So obviously this from here to here it will be d minus x, that's obvious. Okay, so what I will do is this. Let's calculate the capacitance of this. Ab jaan ko beta. So this is an element here, this is an element, and here we have this is one point and this another point. Okay, so this point A and point B, and this here element whose capacitance is dc, and let's try to calculate it first of all. So it's like this. Its dielectric constant here, that's k1, its dielectric constant here, that's equal to k2, and here from here to here it's equal to x. So obviously this is d minus x, so that x plus d minus x will be equal to d. Okay, na beta? So let's calculate the capacitance of this element. This is an element. And what about the area here? What about the area? This area dA, that will be obviously equal to this width multiplied by the depth. This width is dy and depth is a, so it will be a into dy. Okay, now these two, are they connected in series or parallel? Obviously they are connected in series, because the charge flowing through this will be equal to the charge flowing through this. Okay, so they are connected in series. This one and this one, they are connected in series. Now in series, how we calculate the capacitance? We calculate the capacitance, agar aapko yaad hoga, in series we calculate the capacitance like this. K is equal to epsilon 0 multiplied by a divided by summation of ti by ki. This is the equation in series, agar aapko yaad hoga. So we'll use that equation. So here instead of c, I will write dc is equal to epsilon naught multiplied by area के बदले हम क्या लिखेंगे, dA divided by summation of ti by ki, ti divided by ki, ti divided by ki. So it will be like this. It will be like this. That is dc is equal to, here I will write it down, is equal to epsilon 0 multiplied by dA. dA के बाद क्या लिखेंगे, a into dy divided by summation of ti by ki. So summation of ti by ki implies that width of this divided by its dielectric constant, and width of this divided by its dielectric constant. So it will be like this, x divided by k1 plus d minus x divided by k2. Okay, so this is dc. So we are done with the dc. ठीक ना बेटा? So we are done with the dc. So we are done with the dc. Okay, अब ध्यान रखो बेटा. Now next what I will do is I will integrate simply this in order to calculate the equivalent capacitance. Okay, so what I will do is this. Here I will write down the equivalent capacitance. Here I will write down equivalent capacitance. Equivalent capacitance. So how to write down equivalent capacitance now? So this here one element. These two are connected in a series. We have calculated the capacitance of this. This is the capacitance of the element. Now what I will do is this. Now this here one element, this another element, this another element, this another element, and so on. And all these elements, they are obviously connected in parallels. ठीक है ना बेटा? So elements are connected in parallel. This and this, they are connected in series, and then elements are connected in parallel. When elements are connected in parallel, I will write like this: C is equal to integration of dc. C is equal to integration of dc. Now this epsilon naught a is a constant, so I will pull it out. So C will be equal to epsilon naught multiplied by a. Then the integration of all this, integration of dy divided by x by k1 plus d minus x divided by k2. ठीक है ना बेटा, यहाँ तक समझ में आया? Okay, so C will be equal to epsilon naught a integration of dy divided by x by k1 plus d minus x divided by k2. ठीक है ना बेटा? Now you will have to solve this integral. Okay, so as said, it's impossible to solve this integral because this integral contains two variables. One is y, another is x. Okay, so we can solve this integral only if we will reduce it to a single variable integral. ठीक है ना बेटा? So let's try to reduce it to a single variable. In order to reduce it to a single variable, what we must have is that we must have an equation between x and y. We must have an equation between. So let's try to derive that equation between x and y. What I will do is this: suppose that here we have, suppose this angle here is equal to theta. I'll try to calculate the tan theta here. ध्यान रखो बेटा. I will calculate tan theta from this very triangle. I will construct the triangle here. Let me construct the triangle here. It's like this. Okay, so this is here D. ठीक है ना बेटा? And you know this is equal to a. So this is D and a. Okay, so this is here theta. Then there's a smaller triangle like this. There's a smaller triangle like this. Okay, so it is perpendicular here. This perpendicular. This opposite side, that's equal to x. So this will be x. Okay, so this will be x. And then what about this? This here y, isn't it? So this is y. This side. This is y. And this is a. This is a. From here to here, this is a. This is a. ठीक है ना बेटा? So let's try to calculate. Let's try to find the relation between what and what? Between y and x. Okay. So I will try to calculate the tan theta here. In larger triangle, tan theta will be equal to d divided by a, and in smaller triangle, it will be equal to x divided by y. Hence, we are able to derive a relation between x and y. Okay, so let's try to derive a relation between. So let's try to write the y in terms of x. So y will be equal to a multiplied by x divided by d. बोलो बेटा, ये समझ में आया? Y will be equal to a into x divided by d. Okay, so I will calculate dy. dy will be obviously equal to a divided by d multiplied by dx. ठीक है ना बेटा? Then I will substitute it here. Okay, so what it will be? C will be equal to epsilon naught multiplied by a multiplied by a. Then dy will be replaced by what? A by d into dx. So it will be a square divided by d. Then integration of dy के बदले अब क्या लिखेंगे बेटा? dx divided by, and here it will be equal to x divided by k1 plus d minus x divided by k2. Okay, ठीक है ना बेटा? Okay, so I will repeat it again a bit. ध्यान रखो बेटा. First of all, I will assume that it is made of infinitesimally small elements. This is one such element, and this is one such element. Okay, so this here element. This is the element, and in this very element, this k1, k2 are two dielectric constants. Okay, so we'll calculate the capacitance of this. They are connected in series. So series, it will be like this: epsilon naught dA divided by summation of ti by ki by ti is the thickness. So it will be equal to x by k1 d minus x divided by k2. ठीक है ना बेटा? Then C will be equal to integration dc. The reason is that elements are in parallels. The elements are connected in parallels. That's why it's like this. Okay, so C will be equal to epsilon naught a. Then this. Okay. Then this is the integration here. Okay, so we have to solve this integral, but this integral contains how many variables? Two variables, and we have to reduce it to a single variable. Okay, either we have to write y in terms of x or x in terms of y by using this very triangle here. ये बड़ा triangle. This is a bigger triangle, and this one shorter triangle. Okay, in the small triangle and bigger triangle, we can calculate tan theta, and from there we have this equation between x and y. Okay, then calculating y, dy, and substituting in this very equation, we are here. Okay, now we want to solve this integral. You first of all pause the screen and write it down after this. Okay, you pause screen and write it down. Okay, concentrate now. So here we are. Now we have to solve this integral. ठीक है ना बेटा? And we know a generalized formula for an integration. Okay, so that's like this: that integration of f dash x, where f dash x implies what? Differentiation of f of x divided by f of x with respect to x. That's equal to ln of f of x, ln of f of x. ठीक है ना बेटा? Okay, so we have this very equation. Okay, so what I will do is this. Now here we have the function like this. If you calculate its difference will be 1 by k1 and it is differentiation as minus 1 by k2. Difference from x is 1, so 1 by k1, and here it's a difference from d is a constant, so its difference will be 0, its difference will be minus 1, so minus 1 by k2. Okay, beta? So I will multiply and divide that. So I will write like this: c is equal to epsilon naught multiplied by a square divided by d. And here I will write down 1 by k1 minus 1 by k2. And here I will write down integration of 1 by k1 minus 1 divided by k2 with respect to x divided by x by k1 plus d minus x divided by k2. Okay, beta? So this is a function here. This is a function. This is a function. And this it is differentiation. This differentiation is like this. That means we will use this very equation. That means c will be equal to epsilon naught multiplied by a square divided by d into 1 by k1 minus 1 divided by k2. Then integration of this will be simply ln of function. So it is ln of x by k1 plus d minus x divided by k2. And then the limits of integration. Limits of integration for x will be from y to y. That will be from 0 to d. 0 to d. Okay, you check out the figure and you see that the limits of integration will go from 0 to d. Okay, so x is in this direction, that means it will go from 0 to d. Okay, so concentrate here. We are almost done with the problem. Okay, now upper limit minus lower limit. Okay, so it will be like this. This is c, then here it is. This is c. Here c will be equal to epsilon naught multiplied by a square divided by d, and here it is what? 1 by k1 minus 1 divided by k2. Okay, then ln of upper limit minus ln of lower limit, and then we know that ln of m minus ln n will be equal to ln m by m. So it will be like this: ln of, first of all use upper limit, xk by d, so it will be d by k1, and this will be a d minus d, that is equal to 0, so simply it's d by k1, d divided by k1 whole divided by, because ln of m minus ln of n will be equal to ln m by m. We have used that. Okay, then 0, so this will be 0, x will be 0, so this will be 0, x will be 0, so this will be d by k2. So lower limit will be d by k2. Okay, now go for the reciprocal. It will be epsilon naught a square divided by d, and here I will write like this: k2 minus k1 divided by k1 k2. Then here it will be equal to ln of k2 by k1, because d and d will cancel. K2 by k1. Okay, it will be like this: d by k1 into k2 divided by d. So d and d will cancel, that k2 by k1. So finally we have here that c is equal to epsilon naught multiplied by a square into k1 k2 divided by d multiplied by k2 minus k1. Then here it is ln of k2 divided by k1. So this is the equivalent capacitance, and this question has been asked in JEE 2019. Now better is that you just memorize this equation. It's like this: epsilon naught multiplied by a square, and or you can also write it like this. You can also write it like this: epsilon naught multiplied by capital A, where A is the area, multiplied by k1 k2 divided by d into k2 minus k1 ln of k2 divided by k1. Okay, so this is the equivalent capacitance. So this is the equivalent capacitance, very very important. Okay, so better is that you memorize the equation. It's number 1. It's a problem asked in the H-Verma and in Erodo as well, and also asked in the JEE 2019 recent exam. Okay, so pause the screen and write it down. I'm sure you are following me and you are getting it. Okay, so pause the screen and write it down. Okay, another example, example number 4, important, again important only for JEE students. Okay, in this very lecture I will be showing only only those examples which are important for JEE. Okay, JEE only for JEE. Okay, it is also written in Singlish. Okay, so it is a Singlish problem. I have copy pasted it from Singlish. Okay, but the example is like this. Here we have 2 plates. So this is here 1 plate, and this is another plate. Okay, parallel plate capacitors. Okay, the space between them, that is filled with the air. That's what the dielectric constant mentioned. It is equal to 1. Separation here, that is called d. Separation is not uniform throughout, it's non-uniform, and the separation here, that is called twice d, and this is equal to a. Length of this plate, that is called a, and the area is given, that is called a into b, means that depth is equal to b. The depth is b. Okay, so the question is now calculate the equivalent capacitance. So again, since this depth that's not uniform throughout implies that we'll go for the integration. Okay, so again I will assume that it is made up of infinitely many infinitesimally small elements. So this is one such element. Let's assume that this is one such element. Okay, and this element is at a distance of, suppose, x, its width is equal to dx, or you can take the dielectric constant. Let's take the dielectric constant as k. Okay, its dielectric constant is K. So this is dx. So let's calculate the capacitance of this plate, and let's assume that this is origin. So suppose that here this is y. Suppose that this is equal to y. Okay, okay. So let's try to calculate the capacitance of this. It will be dc. It will be equal to its dielectric constant.